Okay, welcome to Unit 1 lesson now. What's the equation? Okay, let's define sequences. So, refresher. Recursive sequence. You need all of these parts. You need the first term. You need your output. You need your previous term. You need your change. And you need the next term. If your first term is 1, your next term has to be 2. If your first term is 0, your next term has to be 1. Now, for explicit, so this is recursive. Let's call this recursive. A formal definition of a recursive sequence. This happens to be a geometric because we're multiplying by 2. Let's look at an explicit or an nth term or nth term or nth term. So now, for the same sequence, we will have f of n equals 1 times 2 to the x power. That's it. 1 times 2 to the x power. I really don't need that dot in the middle between a 0 and a 1 because whenever a number is outside of a parentheses, it automatically means to multiply. And now, here's the deal. If I start this at 0, I'm at 1. But if I say x minus 1, then my n must be greater than 0. So it depends on which way you want to write it. Doesn't matter to me. Pick one, stick with it. I like explicit sequences without the minus 1 because I'll leave the minus 1 for the recursive. But you may see it both ways. Okay, here is our warm-up. So f of x equals 32 times 3/4 to the x. So for f of 0, we got 32 to the 3/4 to the 0 power, which equals 32. Because anything to the 0 power is 1, PEMDAS says do the exponent first, then multiply. So now for the next one. 32 to the 3/4 to the first power. If you multiply that, 32 divided by 8 is 32 divided by 4 is 8. 8 times 3 is 24. The second one is 32 to the 3/4 squared. 3/4 squared is 9/16. And that gives us 18. And then the last one, 32 to the 3/4 cubed. 3/4 cubed is 27/64. So it's 27/2. You can put this in a calculator. The calculator will give you a decimal. Okay, we did something like this before. So let's start. A large cake is in the room. So you got a large cake, whatever your favorite cake is. I like strawberry shortcake or yellow cake with chocolate frosting, but that's me. Now somebody comes along and takes 1/3 of the cake. And then the next person comes along and takes 1/3 of what is left. So you had 1/3, that's a big chunky cake. Somebody takes 1/3 of that. So if you divide that into 3 equal sections, so something like this. Yeah, maybe a little bit bigger, but whatever. Y'all get the idea. So somebody takes this much. And so we have on the second go round, not quite half the cake, but a little bit more a little bit less than half the cake. So maybe it goes to something like that. So, and then everybody comes along and takes another 1/3. So everybody gets a smaller piece of cake because they're taking 1/3 of what is left, not of the total. So there are two charts. One for what is taken and one is for what is left. Now, this one asks you to calculate what is left. So in our first one, we have one full piece of cake. And then in the second one, we got 2/3, that's what's left, squared. Then we have 2/3, what is left, cubed, and then 2/3 to the fourth power. Okay, complete a table. We did that. And this is the cake left, not what is taken. What is taken would have been 0, 1, 1, 1/3, and then 1/3 squared, 1/3 cubed, and then 1/3, 1/3 to the fourth power. Let me erase this so you can see it. Okay. That's just right over here, 1/3 cubed. And let me scribble that out. I can't erase it. I should have written it a little bit over, but it's not the numerator squared, it's the whole fraction squared. So there's a difference between what's taken and what's left, and I need you to get that down. So now we had to write two definitions, an explicit sequence, a recursive, and an explicit sequence. So we're going to write that. And what is a reasonable domain? Domain is the realistic possible inputs. You can't start with 0 cake. We're starting with 1 cake. So our upper end is going to be 1, and then, or 0 cuts. What is a reasonable domain? 0 cuts, because we want to know what's left. Okay, before people take. Okay, so let's do that. I'm going to write the two definitions. Okay. Recursive definition is going to be orange. The explicit is going to be green. So let's start with the definitions. Recursive definitions. C of 0. Before people took a cake, we had one whole cake. So C of n is equal to the previous term times 2/3 for n greater than or equal to 1, because we started at 0. 0 was our first term. So now for the explicit term, C of n is equal to 2/3 n, because we started at 1. And now because we started at 0, we don't need the n minus 1. If we would have started at 1, we would have needed the n minus 1. But we're good. Now, what you want to do is keep calculating this down to get to a number that is just ridiculous. So you have to make up your mind. If you calculate this out, after 9 cuts, you're down to 1/32 of the cake. That's a small piece of cake. So I would say my possible domain is 0 is less than or equal to n, because if nobody takes cake, you have a whole cake, is less than or equal to 10. Come up with a number. The number will seem kind of small, but can you cut a round cake into 32 pieces? Maybe you can. Maybe you can't. I don't know. So that's your judgment call. Okay, this one is an in-class activity. and we'll need some graph paper. So you can read the directions and you can graph your things. You can graph the data tables based on the calculations. I'm not going to do that. Okay, can you represent situations with sequences? Yes, you can.